Hi class, we need to take a look at problem 2, and it has several of almost the same problem, but they're all slightly different. Now, as you're going to solve the first equation, this is an absolute value equation, and let me just reference you to the formulas. So for an equation, you're looking at the boundaries. So in this case, it's going to be scenario A here. If you have an unknown equal to P, so you're going to set or solve the unknown equal to negative P or the unknown equal to P. And we're just going to end up with two possible solutions. So for example, on problem A, we're going to have to solve two technically equations. So the first one's just going to be x minus x is equal to -3, or in the second one, it's going to be x minus x is equal to 3. So I'm setting the negative p and the p. Your unknown remains the same, x minus 6. And then on this one, we're just going to be adding the 6. And the solution here ends up being x is equal to, in this case, 3, or x is equal to the values of 9. So this happens to be our solution. And that's actually it for the solution. They do want us to graph it, so I'm just going to put 0 there, not to scale. So I'm leaving it as 0, 1, 2, and 3, 4, 5, 6, 7, 8, and 9. Now our solution is just going to be technically two values, in this case the 3 and the 9. So absolute value equations, they could have up to two solutions. The reason I'm saying up to two is because some of these may not actually work. Let's take a look at problem B. And notice that problem B, it's an inequality that's bounded with 3. So in this case, it's going to be a less than. And this is going to be scenario B. If you have a less than, the unknown is in the middle, and then you're solving the compound inequality that is stated as less than B and greater than negative, P. They're using P's. So for this one, we would simply solve. So in this case, we're going to solve, and it's still a less than, so x minus 6 is less than 3 and greater than -3. There's your negative p and your p. And for compound inequalities, whatever you do to the middle portion, you're going to do it to all three parts. So in this case, we end up with 3. It's less than x and less than 9. That's going to be our solution. Notice that we're obtaining the actual boundaries. In this case, that's your 9, that's your 3. But since this one is an inequality, let me just put, this will be 0, 1, 2, 3. That would be 9. And in this case, this particular statement says the distances that are less than 3 end up being all distances that are greater than 3 but less than 9. So technically open circles on these two, and then every value in between. So on the equation, our solution was just the two dots or the boundaries. On the inequality, it's every value in between, not including the boundary because it says less than. If it said equal, those two would be solid. And then C, we have an unknown greater than or equal to 3. So in this case, we're looking at scenario C. If it's greater, we end up solving the following inequalities. following inequalities that read x is less than negative p or x is greater than p. So technically the one on the right and the one on the left. So in this case, we're gonna actually solve technically inequality 1, which is x minus 6 is less than or equal to negative 3. Or inequality 2, x minus 6 is greater than or equal to the values of 3. So technically the original inequality with no absolute value and less than or equal to negative 3, which means this region here. And then same idea, we're just gonna add 6 and add 6, and to the other one we're also adding 6. So we would end up with x is less than or equal to the values of 3, or x is greater than or equal to 9. And let me box these two in. So I'm just gonna put 0, 1, 2, and 3. This will be 9. Now this particular one, it's a greater than or equal. So all of our solutions are gonna be including 9 and towards the right, and including 3 and towards the left. So that's gonna be it for this one. Now keep in mind that since we're technically doing the same system in terms of the solution for the original problem, equality means that you have an unknown and your solution is the edges. Less than is technically all the values in between. Greater means that from the edges towards the opposite, towards the positive infinity and towards the negative infinity. And we do have to take into account the boundaries. Here you are including 3 and 9. Less than, you're not including 3 and 9. Greater than or equal, we would include 9 towards the infinity and 3 towards the negative infinity. That's it for problem 2.